Good morning, Miss Maria. Now I can see your screen, but I didn't hear you.
Sorry. Good morning. Can you hear me well?
Yeah, I can hear you well and also the camera.
Okay. Thank you.
Thank you.
Hello, morning. Hello, morning. We don't hear. Can you hear me?
Yeah, good morning. I can hear you. Would you
Okay.
like to share your screen? Would you like to check up your screen sharing and also microphone and camera?
Yes.
Yeah, your camera and your microphone is already set.
Yeah, I share my screen.
Could you please do it full screen?
Is it okay? Can you see my screen?
Yes, also it's all done in full screen.
Okay. Okay. Great.
Thank you.
I stop sharing. So I'm the commander for this incubator 10.
Yes.
So, Mr. Vedong, just want to make sure that the invited talks gonna be 15 minutes each.
Yes.
Okay, I will show the countdown timer on the screen for you like this. It will be 15 for invited talk, and the about the panel discussion gonna be 45 minutes.
Yes.
Okay. For the introduction, you want me to count 5 minutes for you or not?
Yes. Just say let me know the time.
Okay, sure. And about the open discussion, it's 30 minutes. You
Yes.
want timer too? Okay.
Yeah. Yes. I also want this time controller.
Okay, sure. And the conclusion gonna be 10 minutes.
Yeah. Sure.
Okay.
Thank
Thank you.
Yeah. Thank you for the support. It's excellent.
Morning, Miss Anne. Would you like to check your screen sharing, camera, and also the microphone?
Oh, hello, Anne.
Hi, I just unmuted.
Oh, it's great to see you.
Yeah, it's great to see you too. How are you?
Yeah, fine, but it's too long time we didn't meet together.
I know.
Yeah, it's hopefully this ocean decade to bring us some new opportunity to work together.
You haven't changed at all. You're still the same.
Same
when I met you.
Yeah, in fact, I moved to a new university. It's in the southern part of China. It's in the coast of South China Sea.
You said so. Yeah, it looks very impressive. And your new vessel is very impressive. And thank you for inviting me, by the way. I'm pleased to be here.
Yeah.
So I got a question about sharing my screen. There we go. Okay.
Okay. You can try.
All right. How's that?
It's coming.
Doesn't want, oh, there we go.
Yeah, it's coming. Yeah, excellent. We say it well.
Okay. You didn't give me much time, just 15 minutes.
But we have the panel discussion part, and also
I have to have a lot. I have a lot to say, but
yeah,
I have to cut it very short.
I know. I noticed. In fact, I noticed from several resources you are doing exciting work, and yeah, new projects is really exciting. I would like to hear more.
Thank you. Thank you. I appreciate that. I hope we could get a chance to collaborate.
Sure, definitely. So in my new position, we have a lot of seagoing opportunities. I hope is one day I can bring you on board.
Great.
Do you know, we have two invited speakers. The other one is Chunzai. Do you know him before? So Chunzai previously worked in NOAA Miami lab. The first speaker. I mean, the first speaker before you is Chunzai Wang. He's now back to China, but previously he worked in a NOAA Miami lab. Do you know him before?
I don't think so. Is he on the screen right now?
Maybe not yet.
Not yet.
Yeah, let me call him. Let me call him to make sure.
Good morning, Mr. Tuan. Would you like to check up your screen sharing, microphone or camera?
Sorry, do you ask me?
Yes. Would you like to check up?
Yeah, my side. It's okay?
I only hear you, but not on the screen. But
Tuan,
the camera is not showing.
We can hear you. We can hear you. But,
Share to this? Okay, I can.
Okay.
Okay, I can share now.
yeah, excellent. It's great to see you, Tuan.
Yeah, hi, Widow. Yeah,
Yeah.
my talk. Yeah.
Hi, good morning.
Hey, morning, Samkia.
Have you seen it?
Yes.
Can you try make it full screen, please?
Yes, I can do it. Okay.
Yes, excellent, Mr.
Okay, I think it's
Hey,
good. Yeah?
Hey,
Okay.
hey.
May I stop sharing?
Yes, sure. Thank
Okay.
you.
Okay. Stop. Yeah. Okay. Thank you.
Good morning, Mr. Somkiat. Would you like to check your screen sharing, microphone, and also camera?
No, I did not have presentation. I just joined the discussion part. Yeah.
So would you like to open your camera for checking?
Pardon me?
Would you like to check your camera?
Oh yes. Okay. No problem.
Okay, your screen is perfect. Your voice is perfect.
Yeah.
Thank you.
Yeah. Yeah. Why don't? Today I don't have my presentation. I just joined the discussion, right?
Yeah. Okay. Samkia, we for the panel discussion, it's a very freestyle. It's someone prepared several slides like a
Yeah. Okay.
and
okay.
It's not necessary. We just share the knowledge.
Yeah.
I just talked to Chunzai. Oh, Chunzai is coming here. So yeah. So Samkia is Anne is already here. So do you still remember Anne who joined the?
Oh yeah, Anne Cohen. Yes.
School.
Yeah, I remember her really well.
Yeah, we had an excellent time.
She logged in already?
She's here. I just talked to her.
Okay.
Excuse me, good morning, Mr. Wang. Would you like to check off your screen sharing, microphone, and also camera?
Chunzai, would you like to test? We can't hear you, Chunzai. You are muted.
Can you hear me now?
Oh, yes. It's good. We can see your screen. No problem. Oh, it's Trinza. I have to remind you, we have 15 minutes for your talk. I see you have over 57 slides.
Oh, no. The summer is only support slide. I only have 20 some slide. Yeah, so don't worry.
Okay. It's yeah.
So
Thank you.
Is ready? Can I start?
It's wait a minute. It's still 2 minutes more.
Okay.
We don't.
Yes, Duan.
For the second, for the panel, we have a 5 minute each.
On average, but I think more or less we can control the time. But I know now is Riti could not join us today, so you can take Riti's time.
Okay, so I prepare 5 or 7 minutes. It's okay.
5 or 7 is okay. It's Riti has some problem with his leg. He's still in a treatment, so he could not join us.
Sorry for that.
Okay, no problem. So we would like to hear more from you all. I know that this is heat wave is very hot topic. Is everyone want to share more information. I see it's Trenza and also Anne has a lot to say, but no problem. It's we start and we can continue this discussion offline, and we will come up with some common ideas and common actions in the near future.
Wei Dong, I should also say that it's Thanksgiving here in the US tonight.
Okay. Yeah, so that's a great time.
I have family here in my house, so if you hear lots of noise, that's
it's okay.
That's the family celebrating. I also might have to leave early if that's okay, but we can reconnect offline.
Yeah, it's okay.
Hi, and Cohen. I'm Sungkiat.
Hi,
nice to see you again.
It's so nice to see you. Are you in Thailand? It's
very long time, huh? Yes, I am in Thailand.
It's not so long. It's like yesterday.
Yeah.
I was just telling my family about eating the food on the longboat boat. On the reefs in Thailand, and how the boat driver brought the food that his mother had cooked in the morning.
You still remember well, huh?
And after we dived, we came on the boat, and there was this beautiful food. Oh, it was like the best I ever ate. So yeah, so it's not very far from my mind, from my memory.
Oh yeah, that's right.
Like, when were we there? 2000.
I think it's 17, 18, something like that. Yeah.
Yeah, not too long.
You went to Thailand many times, huh?
Yeah, a few times.
Yeah.
Yeah, we can have more time to visit Phuket. That is a really lovely place. Yeah. I think it's time we can start. It's okay, we start?
Yeah.
For me, yes.
Yeah, I think I see a lot of people already there. So we have a 25. That's a great number. So let's start. So thanks our technical support today is who is supporting for our session. So online sessions sometimes it's not easy to organize. So I will have several minutes to brief some information to you. Is I just want to share a little bit my screen. Can I share my screen? It's Trinza, maybe you have to stop sharing your screen for a minute and give me the control for 1 or 2 minutes.
Let me see.
Yeah, okay.
Let me see.
Yeah, you stopped the screen sharing?
Yeah, I stopped, right?
Okay, great, thank you. Yeah, so can you see my screen?
Yeah, we can see you. Yeah.
Okay. So I think is today our focus topic is marine heat wave. So heat wave is we already understand quite well on land because they are influencing our daily life. But over the ocean, we know is even we do not live in the ocean, but a lot of animals that live in the ocean experience heat wave impacts. So that is why we are very much concerned ocean heat wave in the recent years. I believe you will give us a lot of more information. But I would like to first draw your attention at this global scale of marine heat wave. So this is a global distribution of a heat wave. When you look at a global map, you can understand over the Indo-Pacific warm pool region, it's a relatively low activity or low marine heat wave disasters. So this is the first experience, but in fact, the reality is not so simple. But for this Indo-Pacific warm pool region, we know is this SHT is almost the maxima over the global ocean. So any small deviation from the mean state will cause a lot of serious problem. So that means even the marine heat wave activity intensity or events number or whatever is relatively smaller than other regions, but for this region is marine heat wave is a special importance. Another region I want to emphasize, this is a monsoon region. For monsoon ocean interaction has a lot of very unique features. For monsoon ocean, how the ocean marine heat wave develop and how it can be predicted is somewhat different from other oceans, such as in the trade ocean region. So for us, I think is the keywords is the warm pool and also the monsoon region. So warm pool and monsoon region make our South China Sea and the nearby oceans very unique at a global scale. So when you look at the global study, you can understand for this Indo-Pacific warm pool, it's not too much focus till now. It's we have a lot of heat wave study for other regions across the globe, but for the Indo-Pacific warm pool, still a lack of focus and concern. And another thing is I want to say is the marine heat wave is not only physical part, but also a close linkage with the ecosystem. I think most of you will explore this topic further. For South China Sea is a hotspot for biodiversity. So that is why we are gathering here to discuss any common interest in a South China Sea marine heat wave study. I think this is a topic is still a lot of space. So for the beginning, I just want to share this simple information. And then I will give the time to all of you to hear your knowledge and your recommendations for the future. So I think today we have several parts. So the first is invited talks. I am very glad to have two invited speakers to join us and share their recent study. One is Chunzai Wang from South China Sea Institute, which is based in Guangzhou. So Chunzai is more focused on the physical aspects of marine heat wave. And the second speaker is Anna Cohen from the Hui Wushor. And Anna is joined us several years in a Phuket exploration for the coral reef study there. And now is I believe Anne will tell us more. And Anne is leading several very exciting coral reef study projects, and he will tell us about something about marine heat wave and coral reef. And Anne is always very energetic and passionate about to promote such kind of study. I hope in the coming years Anne will join us for South China Sea and have more work in this area, not only in other remote region from us. You should be more closer to us. And following that, we will have a panel discussion. We have invited panelists to share the knowledge with us. You can share with us with a presentation or without a presentation, it doesn't matter. And we have 45 minutes for panel discussion, and followed by 30 minutes of group discussion, and then summarize within 2 minutes and report back. So hopefully we will come up with some a lot of interesting new ideas, new recommendations, and then we can have some common interest and can better to shape up some kind of regional cooperation in the near future. I think Decade bring us a lot of new opportunities. We are limited or constrained by the COVID for too long time, 2 years something. So we are sitting in the office for too long and we need to go out to sea. So hopefully this is starting and we are planning our seagoing days. So I thank you very much. I stop here and we move to the invited session. So first speaker, I would like to invite our colleague, Dr. Chunzai Wang from South China Sea Institute of Oceanography to share his recent study on the South China Sea marine heatwave. Okay, so time is yours, Chunzai.
Okay, I want to first share my PPT. Can you see my PPT?
Yes.
Okay. Okay, let me start. First, I want to thank Weidong, and Weidong is my longtime friend and who invited me give the talk. And my name is Chunzai Wang from State K Laboratory of Tropical Oceanography in Guangzhou, China. Today, I will talking about marine heat wave in South China Sea, and this talk is is from my new paper with my postdoc and just published in JGR Ocean. Okay, so here, how to stop this? Oh, I don't know. Well, let me see. How to make it smaller this?
We're seeing your first slide.
Oh, you it's okay. Okay. So first, I want why we want to study the marine heat wave in South China Sea, and actually in 2020, there's a newspaper, a big newspaper in China report severe color bleach in China occur in 2020. So the question is this due to marine heat wave? So this is the motivation for this study. Another motivation study in South China Sea is that this figure shows the pink dot show the marine reach in China. It says so many marine range in China along the south part of China and along the Henan Island, and the black part is the coral reef. So, which this suggests that if the marine heat in South China Sea, then can affect the marine range and the marine coral reef. So my talk basically have a four part. First part is introduction. This slide shows the definition of the marine heat wave. That basically there are two definitions. One is the fixed, another is the seasonal value of the marine heat wave. In our study, we use the second definition, which means second one, you right one. This slide, I think we don't just show this slide early, and this slide shows the global distribution of the marine heat wave, and show that there's a big region is that in West Pacific Indian Ocean that is blank over there, but this does not mean that no marine heat wave were there. The reason is blank over there is because the no study report yet. So we will do this. This is our purpose for this paper. So we will show South China Sea, the marine heat wave is very important. And also we have another paper that coming out is show the West Pacific is very important for the marine heat wave. This is why we want to do that. So we hope this program will do the West Pacific marine heat wave. This figure shows basically that 2020. You see that the whole West Pacific and Indian Ocean is very important. Show this show the total marine heat wave day in summer 2020, which show that the South China Sea, West Pacific, Indian Ocean all important. So in second part of my talk, I show the marine heat wave in South China Sea and the spatial pattern and temporal variation. The data will use that the daily data. Of course, you have to use the daily data. We use daily data. One is the SST, another is the atmosphere reanalysis field, and all this data is a high resolution. Now, data figure. This slide shows two figures. One is marine heat wave days, and the right panel shows the duration. I mean, all these two figures show that the two very important region. One is in central South China Sea, the heavy marine heat will occur there. Another region that is shown in the Bohai Gulf and the Nansa Island, and it also shows the strong marine heat wave over there. And for the time change, and this slide show two figures. While left panel shows the marine heat day, and right panel shows the duration. So all these show South China Sea, the marine heat wave with the continued increase, and which means this is consistent with global warming, because the global warming induces that the ocean warm up everywhere, including South China Sea. And also we see the figure show the 1998, 2010, 2016 that have a strong peak of the marine heat wave. This is due to the ANSO. We know the ANSO occur the South China Sea ocean temperature will change. This will change I will show you this later. So ANSO is bigger factor for the South China Sea marine heat wave. The next I will show the mechanism, or you can call the factor to control the marine heat wave in South China Sea. I will discuss all the possible mechanism which can make a heat wave occur over South China Sea. The first one is ocean upwelling in South China Sea. And this slide is from early paper by Shangping Xie et al. Basically, this paper shows that this is in June, July, and August. Basically, that the strong wind jet over Yunnan, South Yunnan, which will result the wind stress curve and then induce the ocean upwelling. And ocean upwelling, we know the ocean upwelling will cool the ocean. And then like here in July, right? The ocean over here is cooling. And this cooling water due to the ocean advection, and ocean advection where advect the cold water to the eastward. So in August, the whole central South China they become cooling. The similar, if that no upwelling, this is upwelling because if no upwelling, or upwelling is weak, then the whole South China Sea, central South China Sea will be warm up. This is our result. This situation in 2010, lab panel show the wind stress curve and the SIT anomaly. So basically, this kind of non-upwelling situation induces the warming SIT and induces the marine heat wave in central South China Sea. This is the 2010 case. The next, we take a look at heating flux and atmosphere circulation on the influence on the marine heat wave in South China Sea. And this figure shows regression of the short wave radiation on the heating wave index. We see the over South China Sea that the bigger negative regression over there, which means the short wave radiation will increase or induce the heat wave over Central South China Sea. This is the atmospheric circulation. Again, is there the correlation of the geopotential height and wind with the heat wave index, which basically show the anticyclone over West Pacific, and this anticyclone will induce the wind change and then change the ocean temperature over South China Sea. Next, we want to see the ANSU effect. ANSU effect, this is time series, 2 time series here. The bar shows the ANSU index. So we know that strong ANSU and we have 82, 97, 2019, and a big stronger El Nino, and the blue bar represents the heat wave. So we see the basically we see that the strong correlation between the ANSU and marine heat wave in South China Sea. The basic argument is after strong El Nino occur, after then South China Sea will have a marine heat wave. And this is show that why that the ANSU can influence the South China Sea marine heat wave. The figure show that when El Nino occur, then the ANSU will push the west subtropical high westward, and then change atmospheric circulation, then change the wind pattern, and then change the ocean temperature. This is the basic idea for how the ANSU influence. Now this case show 1998 a case. Show that after the ANSU strong El Nino, and the East China, South China Sea show the strong easterly wind anomaly, and this wind anomaly will change the ocean temperature, and then induce the marine heat wave over Central South China Sea. The final I want to take a look at the global warming. And global warming, what we do here is we use linear trend represent. Of course, this is not a good represent, but we have no other good method. So for time being, we use the linear trend. Here is the linear trend. We use the past 39 observation which show China Sea. It's basically over China Sea is everywhere the warm up, but in this toolbox, the trend is larger, which means that the global warming will induce, it will change the heat wave over there. Next, the last one I want to show is the summary. Summary basically in South China Sea. This figure shows the normal situation. We have a summer monsoon, and like we don't say that this region, the monsoon region, in summertime we have a southwest monsoon, and this monsoon will induce the Ackermann pumping wind stress curve, and then this wind stress curve will cooling the ocean, and eddy, and the ocean advancing where otherwise the cold water to east water, and then South China Sea, Central China Sea is cold. However, I said however, situation different if the West Pacific and atmospheric circulation change. Atmospheric circulation in West Pacific is at two regions. One is as I said, the El Nino, the ANSU can influence West Pacific subtropical high. Another is that we call the inter-ocean interaction, or 3 ocean interaction can change the anticyclone in West Pacific, and this also can change the subtropical high, then change the southwest monsoon wind pattern, then change the wind stress curve, and then change ocean upwelling and the ocean advection, then where the whole Central South China Sea will warm up, and then marine heat wave will occur. So this is the South China Sea, how South China Sea can have a strong marine heat wave. So basically, I stop here. So if you have any question, we can discuss. And if you have any further question, can read the paper. Paper already published in the Ocean. Thank you very much. I stop here.
Yes, thank you, Chunzai. So you share us with a lot of physical aspects of, yeah, really very helpful for us to understand the marine heat wave. Yeah, I think it's we can move on to the second speaker. Is we for the panel discussion and also the group discussion part, we can come back to have more interaction with the Chunzai. Okay, yeah. Let's move to the second speaker. Invite Anna Cohen from Woodscore to share us with a lot of very exciting information. So now it's Anna, please.
Thank you so much for the invitation, Wei Dong, and for everyone for being here. The previous talk was so interesting for me. To look at the physical basis, the physical mechanisms for marine heat waves in the South China Sea. I want to talk to you about the impacts of those marine heat waves, not just in the South China Sea, but across the globe. My talk is focused on coral surviving climate change. And this is really a program that we've launched called Super Reefs, and you can find more information about that on my webpage. This image here is a pristine coral reef, a healthy coral reef in the Southern Line Islands in the tropical Pacific. Coral reefs around the world support the livelihoods of up to 1 billion people, not just by food, but also by income, providing arable land, and also protecting coastlines from storms and waves and tsunamis. But the fact is that there are not many reefs today that look like this one in the Southern Line Islands. And the reason for that has to do with the increase in ocean temperatures associated with anthropogenic CO2 and methane emissions. Across the global tropics, ocean temperatures have increased approximately 1.1 degrees Celsius since the Industrial Revolution around 1850 AD. But it's not the secular trend specifically that is causing the problem for coral reefs across the global tropics. What's causing the problem are these marine heat waves. In many areas of the ocean, especially in the central and eastern tropical Pacific, marine heat waves have been around for a while, or at least El Nino southern oscillation events have been around for hundreds of years, maybe thousands of years. The problem is that these marine heat waves, both in their geographic extent and the intensity and their frequency, has been increasing in the last 40 years. What marine heat waves are doing in terms of temperature anomalies are causing increases in temperature of up to 4 or 5 degrees Celsius for multiple weeks, even months at a time. And that is the problem for coral reefs. So what happens is that the reef building corals are living in a intricate symbiotic relationship with single-celled algae called zooxanthellae. And those zooxanthellae are a primary source of food and energy for the corals that allows them to build the reefs and provide the ecosystem that hosts many, many marine species and provide the livelihoods for millions and millions of people around the world. In the left-hand picture, what you're seeing here is a coral that has been exposed to intense heat. What was once a very colorful, beautiful branching coral is now white. It's not dead yet, but it has lost the symbiotic algae that live in its cells and feed it. So it's essentially starving. Now, if the temperatures don't come down and the algae aren't able to infect the coral will die. It will die of starvation. And so what you're seeing on the right-hand side is this coral on the left, several weeks later, dead, all the coral polyps are dead, and it's covered in a green mat of algae. This coral isn't going to come back. In the 2015 El Nino, which was caused an unprecedented heat wave across the tropical Pacific basin, some of our most healthiest, most pristine, most productive reefs in the Pacific succumb to these unprecedented temperatures. This is a picture taken in April of 2015, before the peak of the heat wave. We were able to get out there in November of 2015. And once we were out there, what we saw was the entire reef system was, the entire coral community up to 90-foot depth was bleached. There was not one coral in sight that wasn't bleached and turned white. And when we returned in March of 2015, 97% of the corals were dead. What this means is that marine heat waves are really the most effective mass killer of corals in the world. You can take a healthy, pristine coral reef with 75% coral cover, huge fish biomass, incredible ecosystem, and decimate that reef within just a few months, just by raising the temperatures during a heat wave. The truth is that up to a quarter of, probably more, this is a conservative estimate, of coral reef surface area across the world has been lost to ocean warming, specifically to the increase in intensity of frequency of heat waves since 1982. That's just in the last 40 years. We've lost 25% of living coral reefs. So as scientists, as conservationists, as coral reef managers, what we're faced with is an ocean that is continuing to warm, CO2 emissions that are continuing to rise, heat waves that are continuing and projected to be increasing in frequency and intensity over time. So what do? We turn to nature. And what we find in nature is that not all corals respond to heat the same way. So what you're seeing in this photograph is a few coral colonies photographed during a heat wave. And what you see is that there are three colonies here, this one, and this one right here, that are bleached white. They are succumbing to the heat. But there are three colonies also that seem to be tolerating that heat wave. And this is what we are focusing on in our Super Reefs program. This ability to tolerate extreme heat is not only limited to individual corals, but we're starting to see this in large coral communities, so large sections of coral reef area. So here I'm comparing a coral reef community dominated by tabletop acropora on a reef in the Central Pacific and on a reef in the Great Barrier Reef. Both have been exposed to the same levels of heat stress, and yet this coral reef community survived, whereas this one didn't. The one on the left is obviously more heat tolerant than the one on the right. This is what we call the super reef. The super reef is a reef community of corals that's able to episodes of extreme heat. And we have discovered super reefs, large coral communities of thermally tolerant corals that are able to resist heat waves in many parts of the ocean. We found them in Thailand, and Samkhya is aware has worked on those. We have found them in the Central Pacific. We have found super reefs in the South China Sea. We have found them in the South Pacific in the Southern Line Islands. And there are many more super reefs out there for us to discover. And we are working with coral reef island nations and conservation organizations to protect them. Why do we want to protect these reefs, these super reefs? Well, as the oceans continue to warm and as heat waves become more frequent and more intense, we need to protect those coral communities that can survive this onslaught of heat so that they will reproduce, producing thermally tolerant coral larvae. You can see here a super coral releasing eggs into the water. And those larvae will restock neighboring reefs that have been decimated by climate change and ocean warming. We're also able to use these heat-tolerant corals. We're able to propagate them and utilize them in the restoration of reefs. So what we're essentially doing here is accelerating nature's own way of keeping coral reefs alive during ocean warming. The problem with these super reefs that we're finding is that they're not protected, not necessarily protected from other human activities that can kill them. So, for example, this super reef in Palau that we've documented through multiple heat waves, we've documented the super reef surviving multiple intense heat waves, including the 1998 and the 2010. There is a proposal to build a hotel on the adjoining reef that is the route for larval migration from these super reefs to neighboring areas. In Tuvalu, what we found is that the super reefs that survived the 2015 heat wave, this extensive area of reef on the north of Tuvalu's largest island, is currently being dredged right here to build a harbor. So what we're intending to do with the super reef program is to identify super reefs and ensure that they're protected from these other activities that can kill them, and allow them to reproduce and propagate to help to recover neighboring reef systems that have been decimated by ocean warming and heat waves. And what we have done is we have met with and talked with many leaders of coral reef island nations and gotten commitments that if we can find these super reefs, they will make the commitment to protect them from other human activities. The question is, how do you find super reefs? So if you look at across the global ocean, or across the global tropics, there are thousands and thousands of reef systems. So what we're essentially doing is looking for a needle in a haystack, right? So how do you do this? Well, we know that super reefs exist, or thermally tolerant coral reef communities exist in areas that are naturally hotter, in areas of reef that are naturally hotter than other areas. We know that thermally tolerant corals are associated with areas on the reef that have high diurnal variability. We also know from our work in Thailand with Samkiat and work in the South China Sea that corals can survive heat waves if they are protected by oceanographic processes such as internal waves, which cool the areas during heat waves. The problem for us in finding areas that are chronically hot or highly variable or sheltered by internal waves is that the reef environment is very different from the open ocean. And most of the open ocean models, the satellite data, cannot resolve the conditions on a reef. So what we started to do is to build fine-scale hydrodynamic models, three-dimensional, high-resolution hydrodynamic models of individual reef systems. And what these models are doing is simulating with a high degree of accuracy the conditions on the reef system down to 200 meters depth. So this example here is Canton Island in the Central Pacific. This is one of our super reef sites. This is a Google Earth view on the left. On the right is a snapshot from high-resolution hydrodynamic model run that we did of Canton during 1 day or 1 hour in 1 day in 2012. And what you see immediately when you just look at that island is that the temperature is hugely heterogeneous across the island. So in the red areas here, the lagoon is naturally hot. It's cooler here, but still warmer than the open ocean. And this is exactly the information that we need. So we're looking for these chronically hot areas because these chronically hot areas are the ones that have the likelihood of housing thermally tolerant corals. What the model simulations are also doing for us is identifying where on the reef, not just at the surface, but through depth, we can find areas that have high diurnal variability. And in Canton, we find these areas very close to the channel, where I have drawn a red circle here. So what I'm showing you here is a few days in the life of this reef. What you're seeing in the colors is the temperature at hourly resolution. The hydrodynamic model is resolving the temperature at 50 cubic meter resolution. It's a very, very high resolution. Satellites cannot do this. Satellites are also only skimming the surface. The model, we can look through this reef system down to 200 meters depth. We also validate our hydrodynamic models against strategically placed in situ logger data. So what you're seeing on the left-hand side in the red is the model output at 4.5 meters depth during the 2002-2003 heat wave on Canton. And the black is the logger data, the in situ temperature logger data for that site. Here again, we're seeing a comparison between the model output at 37 meters versus the in situ logger data at that site. And here, the logger versus the model at 3 meters depth during the 2015-2016 heat wave. So the model is simulating the temperatures on the reef at 50 meters resolution within 0.2 degrees Celsius. So we're very confident in this reef system and in our Marshall Islands, as well as in Palmyra, where we've also built hydrodynamic models, that we're capturing the conditions at very high spatial resolution, very, very accurately. What we do once we've identified areas on the reef that are either chronically hot, such as these in the north west corner and the southwest corner, that are highly variable, such as just inside the channel, or that have oceanographic processes like on the southwest corner here that are cooling the corals and keeping them alive. Then what we do is we bring our stress tests to the reef, our thermal stress tests to the reef, and we sample the corals, expose them to prolonged increased heat stress, and determine if these corals are indeed supercorals. In addition to that, we can quantify the temperatures that these corals can withstand. So here are two corals of the same species on the top here, exposed to temperatures of 30 degrees Celsius for several days. On the bottom panel here, what we've done is we've increased the temperature to 34 degrees Celsius. And what you see is that the coral on the left bleaches at those temperatures, but the coral on the right doesn't. And those corals are coming from areas, this coral, this thermally tolerant coral, is coming from an area on the reef that is chronically hot, that our hydrodynamic model identified as being chronically hot. And that is consistent with our prediction of where these thermally tolerant corals are going to be. So once we've, so really what we need to do is to understand at a very, very fine scale the conditions on the reef system. The coarse scale satellites, the coarse scale models, the open ocean information is not enough for us to understand what's going on within the reef system and to find areas within the reef system where these thermally tolerant corals will reside. It's absolutely critical for us to build these fine scale hydrodynamic models that we then compare against strategically placed thermodynamic temperature loggers to assess how well our models are doing. Once we find these supercorals, we validate the temperatures that they can withstand, then we confer with the governments of those coral reef island nations, provide this information to ensure that those governments and the managers of those coral reefs understand that these super reefs are really the reefs that are going to be these are the future of coral reef systems under ocean warming. This is really a hugely multidisciplinary effort involving understanding marine heat waves and how they propagate through the ocean, what the future of marine heat waves is under global warming, how the marine heat waves affect the reefs specifically, where we can find corals that can tolerate these heat waves, and then really needing the governments of those countries to protect those coral reefs, those very special reef systems. This is an image from the Southern Line Islands Marine Protected Area, Millennium Island. It is a super reef. It came through the 2015-16 marine heat wave, unprecedented heat, in pretty good condition. It is a reef within the Republic of Kiribati in the Central Pacific. I hope that I've left you with something of interest to ponder, a wave that clearly ways that science can really help in the preservation of coral reef systems through ocean warming in the 21st century, and hopefully something we can discuss in our future discussions. Thank you so much.
Yes, thank you, Anne. It's a very impressive presentation. So hopefully you can still have several more minutes to stay with us in a panel discussion, group discussion. So it's up to you available. I know you are in a family holiday there. Anyhow, yeah, we will keep some questions to a later stage. We are already several minutes lagging behind the schedule. Okay. So we move to the panel discussion part. It's for the panel discussion. So firstly, I will invite each panel to share their information or understanding or interest, and then we can come back to a group discussion. So firstly, I would like to invite Dr. Vo Sĩ Tuan from Vietnam to share with us his experience and interest with this marine heat wave. So it's Tuan, would you like to start?
Yeah, thank you, Wino. May I share my screen?
Yes, please.
Yes. Colleagues and friends, thank you for giving me an opportunity to say something in the incubator on the heat waves. So my talk is about the prediction on increased sea surface temperature and its relation with coral bleaching. And this morning we have been listened to the some presentation on the heat wave and also the coral bleaching. So I would like to have some brief on the smaller scale. And as you are aware, the tourist operator and fishermen have been aware on the negative impact by coral bleaching and possible mass mortality caused by bleaching to their livelihood. You can see the figure on mortality of coral, and then the fishery resort become poorer and no more beautiful scape for tourism. The scientists have understand the severity of accumulated impact from the water warming and human harmful activities. And many publications have discussed about combined cumulative impact, high temperature, high pressure, so more susceptibility of corals. And we understand that the minimizing intensity of human impact during bleaching period can help reef to be more resilient. And in practice, some intervention have been applied, such as in Thailand, they have the temporary closure of tourist activity to minimize impact and to support coral reef to be resilient under increased sea surface temperatures. And the figure show you very popular knowledge about the coral reef is under threatened due to cumulative local and global. The local is mainly human activity, global is mainly from the climate change. So this slide show you some the figure about the data from wounding from NOAA for the high temperature sea surface temperature in 2016. And you can see in the cycle, it is the wounding for the more sensitive area for coral bleachings. So through many publications, we found that the bleaching become more frequent. Many reports on the bleaching in the region in most areas in 1998, 2010, 2012, 2014, 2015, 2016, 2017, and maybe 2018 in some country, and 2019. In the Western Pacific, the bleaching in 2016 is quite serious compared with others. However, you can see the figure is quite different among the regional large scale. Sorry, I saw. But for the local level, for the site level, these are result of the study in the project cooperation between Vietnamese scientists and also from the Coral Watch unit under NOAA. And we found that the variation of temperature, you can see here the sea surface temperature and the degree heating week can have a very good, very tight relation with the coral bleaching. You can see it here in 2010, 2016. Yeah, it is very serious. You can see the figure. And you can see here however, we can see the relations between the degree heating week and coral bleaching. But severity of bleaching is quite different from area. You can see there the figure for Southeast Asia, published in the regional report, and you can see the severity of bleaching is quite different from country. And it not only from temperature, but also possible impact from the human activity. So it is important that the reduce of human activity is critical to assist resilience of coral reef, and therefore human action will decide future of coral reef in the region, as our see in the figure for whole region. Smaller scale, and this bleaching in 2010, you can see the very, it is very serious in Phu Quoc Island, in the Gulf of Thailand. The same record in Thailand through some publication, previous publication. And 1/3 coral died following 3 months of bleach. You can see the figure in some area in Phu Quoc. It is a very, very high level, like 90% of coral bleach. And after 3 months, 1/3 died. In Condao is here in the offshore island. You can see the around 30–40% of coral bleach. However, in central, south central, and very few coral bleach, only 1% in Nha Trang City and 2.5% in further south of Nha Trang City in Ninh Hải province. That is the figure in 2010. Contrary, in 2019, you can see here, you can see the percent of coral bleach and non-bleach and total cover of coral here. In Nha Trang, it is more than a half coral, more than a half coral bleach. And the same in Ningpho province for the south of Nha Trang city, and 40% for the cover. You can see here, it is more bleached coral than non-bleaching corals. Phu Quoc, where there existed the very severe bleach in 2010, now only very few coral bleach in Phu Quoc Island. And Con Dao, it is also not high level of coral bleach. You can see the situation, quite different from area. So the last slide I'd like to show you about the gap to be addressed in terms of science. We found the relation between degree heating width and coral bleaching, but we cannot clarify the severity level of bleaching in relation with the increased sea surface temperature. And given the fact that the bleach sustainability of coral is quite different among areas, so we need to have the prediction of bleaching level at small scale, not only the regional scale or province or like we can see the figure from the many wounding now in the world. The prediction is longer in advance is better. And this is very useful for application in management. The tourist sector can close of activity during the sensitive periods, and we can stop dredging to minimize sedimentation to the coral reef to reduce the pressure. We can reduce construction on the coastal land and islands, and if we can predict the bleaching, and we can change the planning fisheries. And we can proceed some other interventions, such as the shading shallow reef and increase movement of water or something. Yeah. So I also informed that in framework of IOC WESTPAC, the coral reef project, working closely with the ocean forecasting project, and we propose a case study on the application of ocean forecasting system product for the coral bleaching at the smaller scale, with including not only scientists on oceanography, biologists, but also the local people, tourist fishery sector, and MPA management, and how we can predict and to have an intervention to support coral reef resilience under pressure, increase of pressure from human activity and climate change. Thank you very much.
Yes, thank you, Duan. Thank you for your national study case study. I think it's along the coast of Vietnam. You already show us several case studies for the coral bleaching and the marine heatwave. I also remember the Chen Zai already mentioned in his talk is Vietnam coastal upwelling not only influence the local scale, but at a larger South China Sea scale. So you will say it's in the central part of South China Sea. The marine heatwave is very closely related to your coastal upwelling variabilities through the oceanic advection process. So that means your coastal anomalies is not coastal impacts, but it's larger regional impacts. So we are very much looking into the future study on these local and basin scale connections.
Yeah, thank you, Wei Dong. I can give you some a little bit information about that. And in this area, we have 4 MPAs, 3 existing and 1 proposed MPAs in the area. in South Central. So in the ecological network of MPA in Vietnam, we identify that this area is very important for how to say for resilience of coral reef under the increased sea surface temperature, and like the source for restoration, for rehabilitation of coral reef under the pressure, like at the Incubator Island further south, they're very serious in some area, in some years. But the source from South Central in upwelling area will be helped because we have a high temperature in summer, May, June, July, but it is the same June, July, August is the month of upwelling, and the sea temperature can decrease immediately to help the shorter pressure to coral reef, and then coral can survive, and to provide the sources for restoration of coral reef, not only along the coastline of Vietnam, but I think also for the South China Sea. Thank you.
Yes, I fully agree with you. This upwelling system is very important, just like Chun Zai and also Anne mentioned. It's similar to what we have working with Samkia in NMSC. So upwelling is a very important process to be further explored. Thank you, Tuan. So next, I would like to invite a Samkia from Thailand, PMBC. Previously, I think Samkia has a long experience with PMBC and working in the region, and now he's working in a Western Pacific Aussie WESTPAC. So I welcome Samkia to share with us. Samkia, please.
Yeah. Thank you very much, Weidong, for inviting me to join the discussion. I have few points, would like to share with you. The first of all, I would like to say that in Thailand, and our neighboring country like Myanmar, Cambodia, southern part of Vietnam, Malaysia, and northern part of Indonesia, is for the impact of marine heat wave or period of marine heat wave, is more or less we are similar. But the period is very critical for us. It's to be late of April and in May, these 2 months very critical because of this area. We, intertropical convection zone will pass to this area during this period, and then it's normally the maximum sea surface temperatures in this area around late of April to May, and then that's why we are watching the fall. In case of coral bleaching, these 2 months is very critical for us. But for many years, we have been working together. I have been working together with Weidong. It's more than 10 years ago. We learned a lot about the process. And one thing, just for the statistical of the ENSO, we know that, during the late of the year, we have the strong El Nino, in that in the year, particular from mid of the year to late to the December, right? And then when the strong El Nino start to declare, and then we can see that it will follow with those kind of high sea surface temperature will occur in this region that I mentioned to you before, Thailand and neighboring country. Is that, for example, is from statistical, we have been checking on statistical, for example, in 1983, 1998, 2010, 2016. We can see that the year before, the late of the year before, we have strong El Nino, particularly if stronger than 1.5. We can see that in following year, in the earlier following year, we will have the high sea surface temperature. That is from the knowledge, from statistical information. That's why in Thailand in 2016, we are quite successful to predict, coral bleaching will occur at least about 5 to 6 months in advance, particularly in 2015. In August, September, October, we already predict that in early of 2016 we will have the coral bleaching. That is a knowledge. It provides to the Department of Marine and Coastal Resources, who in charge about those kind, coral beach, coral restoration, coral management. They can make the plan in advance to manage about if the coral bleaching occur, what we have to take the action immediately. They are working very close with the national park, Marine National Park, and our local authority. That is quite successful learning in 2016. Yeah, and that we can say that for our knowledge, when we come to the local, you can see that it already mentioned by the first speaker that you see that recently in 2010 and 2016, the coral bleaching or even the high sea surface temperature, these 2 years, the degree, of the impact is different, In 2016, we have less impact than 2010 in terms of the comparison of the 2 years. Because when you're looking on the El Nino, these 2 years is quite different. In 2015, El Nino is much stronger than in 2009. But in terms of impact, 2010 is much stronger. But that from this one, we think that maybe they have other local mechanism, it may be involved, to make those kind of degree of the heat is different from these 2 years. Particularly when I observed in 2016, we can see that when compared to 2010, when those kind of high sea surface temperature, they came from the central part of the Indian Ocean, they came to the western part of the Sumatra, and then they move immediately to the Andaman Sea. And then we get the impact very early and very strong. When compared to 2016, we can see that the movement of the high sea surface temperature, it came to the western coast of Sumatra and it stayed there for a while. And then they move into the Andaman Sea. And then there's a coral bleaching in 2016. It occurred in the mid or late of April, even compared to 2010. It started in early of April. And then we think there's still a lot of local mechanisms we still don't know. And then maybe this kind, for this group, we set up the working together, maybe scientific and fulfill on this kind of the knowledge. Particularly from the presentation today, we can see that atmospheric circulation that mentioned by the first presentation is might be involved on this one as well. That is, and that is very important for spatial and temporal impact. The mechanism of that's very important. But the fourth point I would like to mention about scientific knowledge. We know that it's for the government. We appreciate that kind. The research has been do the research and understand the mechanism. But the government, in terms of UN decade, is in the user. The government is very important. We would like to know, if we can predict it, what is going to happen, what the degree of those kind of heat wave, what it will happen. In advance, it will be help the government a lot in terms of the people working for the coral, in terms of the government to prepare that kind of action to take action immediately when they have the impact, on the locals, right? And then the one point as well, and we know that as Tuan mentioned, it's a local knowledge also very important, particularly about the upwelling. For example, in Thailand, we know that we have a strong internal wave. We have the internal waves, and then normally the period of internal wave, they came very close to the shore, almost the same period up in early of April, and then that is also can help to mitigate the impact of from the heat wave, marine heat wave as well, if they occur, right? And then the last point, I would like to this group, we have to think, what we can work together in terms of the scientific to get understand mechanism, and those mechanisms, what we can do, those kind of predict of the mechanism that also can help the government a lot, to in terms of management. It's one thing, one example I can give it to you. During I work at the PMBC, I had been work a lot on those sea surface temperature data, and I work with my colleague working on the coral. Finally, in 2019, we get that knowledge to analyze that knowledge, and then we develop those kind, coral bleaching alert. It's from the local, because we know that we have the NOAA. They did very good job. They do the large scale, but for the local scale, sometimes difficult to use that one, because and then those one they use maybe in the 2 or 3 months in cover in general. And then for us, we do daily a warning system. We are based on those kind of available remote sensing data, and then we can do one by every day. At we can do maybe few days in advance. We are using one of the data from the WESTPAC project ocean forecasting system, because of at the Phuket, we set up those kind of high performance computer do the forecasting those kind of ocean, 3 days in advance. We also use that data. And then from that one, it's we use that knowledge from us at the local and develop this kind of the website for the coral alert, And so far, during last year, it's working very well. It's working very well. It's met very well. Particularly even earlier this year, the system and don't have any warning of the coral bleaching at all. But in the real system, also the same. We didn't get any problem from the coral bleaching. Yeah, that is. I think at Tuan mentioned, our colleague from Vietnam. This system maybe it's a region in terms of the regional coral bleaching. Maybe we need to get working together, learning from each other. Particular the data from the local. This can be help a lot to develop this kind of system. I think it's my suggestion, and I have only I will stop now. But I have some of my colleagues I saw is Lalita and Cheremblat also join this meeting. If they have any additional information would like to share with us, I think it will be good. Yeah, thank you very much, Wai Dong.
Thank you, Samke. I think I'm very impressed by a lot of data logger study carried out in Thailand. So you are collected the in situ data, and this kind of data is very much enhanced our understanding from the satellite. And plus, I think you are working also with the ocean forecasting system to combine the in situ data, satellite data, and forecasting model together. So you have established a system, at least a testing system for the coral bleaching early warning system. So that is very impressive. I think in the next step, we can share a lot of experience from you and with other nearby countries to have a better regional picture. So also another point is from experience working with you in Thailand, I think the internal view is another critical physical process that very much related to what Anne called a super reef. So it's a internal view, upwelling, and all this process we need to pay more attention in the next step. So
yeah. Why don't could I have some a bit more additional about the super coral, and then you mentioned about Andaman Sea, about internal wave. We have been done a research with my colleague from Philippine from PhD student. We found that even though the coral in the area approach to the internal wave, it's happen when they get some kind of the coral bleaching, they can survive or recover very well when compared to other area. That may be it's similar. I don't know that in Vietnam you have observed about that or not. Maybe more or less the same. Coral in the area of the fluctuation of the temperatures, high fluctuation of the temperatures, it can be tolerant to this kind of impact very well. Thank you, Wai Dong. Hello, hello, why don't you hear me?
Wai Dong is frozen for me.
Yes, maybe his internet connection is not stable.
I can hear you, Samket.
Samket, you are muted.
Okay. Didn't you hear me when I mentioned about the internal web? Yeah, because from our study we found that in the area exposed to an internal web, normally the coral reef in that area have the it could tolerate to the heat better than the other areas. Yeah, that maybe the upwelling or internal wave can mitigate this kind of impact.
Yeah, so the internal waves keep the temperatures cooler, right, during the heat wave. So it's like air conditioning for the corals. But we don't know what the heat tolerance of those corals are. I think that's a really important question, because they are seeing very high fluctuations in temperature on a very short time scale. So one might predict from what we know about thermally tolerant corals, that they might even be thermally tolerant. Not only are they protected from the heat, but they might also have high thermal tolerance. I don't think anyone's tested that yet.
Yeah, I think, and we had been did one of our PhD study had been tried to test that one. They bring that the coral from the area is approached to the internal wave, and then from other area do the experiment. They can see that the coral from the area from in the internal wave area much higher tolerant than the coral from the other area.
Oh wow! Oh wow! Is that published? That's really.
I think it's one in the thesis and in the thesis of the student. I'm not sure that I have to check it. Yeah.
That's great. That's a big question for us in the, I mean, for everybody, for Dongsha and also for the Thailand reefs. Be good to talk more about that.
Yeah. Yeah. I hope you can come to join, you know, to PMBC working on that with my colleague later. Yeah, more.
Hi. Hi, Somkiat.
Yes, Nan, you can.
Can I share something?
Yes.
I would like to share about the coral bleaching forecasting that we done together with Dr. Chaleblat. In the case of in the Gulf of Thailand, coral bleaching is in many cases that happen because of its low tide. It's exposed to the air during the lowest tide. So and in this case, because of in the past, I'm not sure for the data, but we use the report of coral bleaching to include to analyze or relate with the temperature. But what I found the last year, I think coral bleach in the Gulf of Thailand because of it's exposed to the air, not really about the temperature, because of like exactly below some colony on the shallow area is exposed to the air and it's bleached only the part that exposed to the air, and just the part that really behind to the water, they're not bleached at all. So this one has to be careful when we collect the data from the volunteer or from the many places that they report it bleached. And if we use that data to relate with the temperature, it will be make us confusing sometimes.
Lalita, hi, it's Anne. How are you?
Hi. Hi.
It's nice to see you.
Nice to see you too.
So the question there is, are the corals exposed at each low tide or at spring low tide or only during the heat wave? And are they bleaching every time?
Actually, in the Gulf of Thailand, they have the specific time. For example, during the June, July, August of every year, they will expose to the air longer time. Yeah.
They're bleaching every time. Are they bleaching every time?
To be honest, I'm just come here for sure these 2 years, these 2 past year, but I'm not sure for the longer from the previous.
They die?
Yes, they die. And now I just tag those parts that die and see how they're recovering, how fast, because of they expose almost every year and they die. And for the next year, it's like they can recover quite quickly, but I'm not sure. So this time I just tag exactly the same colony to see how they recover.
And is that the Acropora?
Both Acropora, Polites, Pavona, every species that's like on the leaf frat.
So you're trying to understand if it's the exact part that is exposed and dies that is recovering, or if it's new growth that's recovering. If you're seeing new growth.
To classify these issues, in the normal condition, if coral can develop, so it means that they can survive. Only extreme the condition, they have a problem. We have to identify the situation. For massive porites, many coral in the tidal areas, and they develop slowly, and they have the in the top, they have a part die.
Yep.
Because they are dry, no waters. When low tide, for long time, it is not related to temperatures.
Yes, that I would like to mention. Because in the past we use that data to relate with the temperature. You know,
some very big massive coral, we call that is the mini atoll, because they have the in the middle they cannot develop. It is the
micro atoll.
Not under not under pressure. It is condition. For acropora, multipora, some coral can exposure under low tide, but in the condition no bleach, they can survive without extreme condition with high in some years. Not annually die and develop. I have not seen any place like this. That's my experience.
Yeah, sorry, I have to disturb you. I think why don't still could not come back yet, you know, because we still have four people to share their knowledge. If you don't mind, I will help why don't to convey this kind of, you know, this discussion to those 4 people to join to exchange their experience before we came back to discussion again, because we still have 40 minutes. And we have 4 people. If those 4 people, you can make the short, you know, chat of your knowledge will be nice, and then we have more time to discuss about it, right?
Yeah.
If you agree, I will help. Why don't to convey this kind of, you know, discussion? Okay. I think next I would like to invite Augie, for our colleague from Indonesia. And then Augie, you are already in the rooms. Augie, if you share art, please say something. Okay, if Augie is still not here, you are here. Okay, Augie, yeah, please.
Can you hear me? No.
Yes, we hear you. Yeah, that's good. That's good.
It's a
It's
bad
the floor is yours.
Sorry. Okay. Thank you very much. I think it's a very interesting talk and discussion. I would like to appreciate all the speakers for presentation. You share a very good knowledge. And I think from Indonesia, we already started to do some modeling on the coral distribution. And we found that acropora in Indonesia by 2100 will be changed about 22% of their distribution and true in Indonesia. But I think if we can combine with Thailand and Vietnam and the Philippines, maybe we can have another picture for the coral distribution. So that's a point from me. And also the other thing is about the fisheries. We also started to do for also tuna fisheries in Indonesia, because we got the information from the tuna commission in the Pacific that probably tuna would like to migrate more in the east coast of Pacific by 2019. So that's why we have to learn how can we protect tuna. Well, I think that's enough for me, because I think
thank you very much, Augie, for your sharing. What are you doing in Indonesia? I think why don't can incorporate your proposal, in when he developed this kind of activity in near future. Thank you very much, Augie. And the next, I would like to invite our colleague from Cambodia, Lady Miss. You are already in the rooms. If you are, please share. Please let us know. No, it's no. He's still not in the room. And then I will go move to the next one. Is when Letty come back, I will invite him again. Next is our colleague from Malaysia, Fasil. Yeah, Fasil from the UMT from Malaysia. Please, Fasil. Fasil, are you in the rooms? Are you in the rooms? Let us check in the rooms. Yeah.
Mr. Sumkiat, Rithi and Fasil not in the room, so we can move to.
Okay.
Maria
Otherwise,
now.
I can move to the last one. The last one is our colleague from Philippines, Maria Vanessa. Yes, Maria, you are in the room. If you are, please let us know.
Yeah, hello, good morning. Can you see my
okay.
screen?
Okay, I hear you. Please go ahead.
Okay, thank you for the opportunity to share our efforts in the Philippines. So what you're seeing on your screen now is a Facebook page of the Philippine Coral Bleaching Watch. So this is a platform, a citizen science platform where any diving enthusiast or even those who are snorkelers have the capacity to share and report coral bleaching in the places in the Philippines. So this so if you want, for example, if you want to report coral bleaching, you just need to use this application. And if you tick on this application, these are the following details. So name of diving sites, the locations, latitude and longitude, date of observations, and if you have submitted this report before, and then if the other question is, did you see bleach or fluorescent coral in the area at the time of your report? And then did you see any other reef threats? So aside from, of course, the increased sea surface temperature, the following threats are also included on the list. And in addition, the data on the temperature, what is the temperature on the water in degrees Celsius, as well as the depth of the location. And the pictures will be submitted in the website. So the group are collecting this data, and I just want to share some outputs. So this Philippine Coral Bleaching Watch is led by Miss Milidel Christine Kibilan and Daryl, Irina, and the citizen. So on Philippine Coral Bleaching Watch. So what you're seeing here is on the dots are different locations where reports were done at various level of severity. So 0 if it's black, and then 5 most severe if it's dark red. So what you're seeing, so it's quite interesting that almost all of the country experience bleaching, but most of it are here, somewhere in Luzon. So the data was collected from 2015, 2016, and 2017, and most of the reports were done in 2016, and majority of bleaching, in fact, happens from April until July, and actually even in October. So, and the trend for 2017 is that in July and August, there's high bleaching event. So these are sample photos of coral bleaching in the Philippines. So unlike what I have learned earlier, that coral bleaching in other countries, they decimate all the corals. Fortunately, in some areas in the country, they're not bleached. So I think this is one way to identify what Anne Cohen mentioned earlier, the super reefs. Yeah, so I suggest that in other countries, maybe at this forum, we can do a collaborative work on citizen science approach to be able to monitor coral bleaching. Okay, so in addition to hard corals, because majority of the studies on coral bleaching is focused on hard corals, right? And our lab is currently monitoring not just hard corals, but soft corals, I think, as well. So I think we can also use this as indicator species to monitor and to understand coral reef resilience. So what you're seeing here, actually this is the sampling design. So what we did was we monitor several sites in northwestern Philippines and checked for bleaching. So I'm just showing you here the trend of the actual and temperature data based on satellite data. And what you're seeing is that in July, from June to August, the temperature is at its highest. So I just want to share some of our results on soft coral bleaching. So out of 2,073 colonies, we monitored 3 genera, Sinularia, Sarcophyton, and Lobophytum. So these are some representative pictures, and the point of this slide shows that it's actually genus specific. So for example, the most sensitive to coral bleaching are Sinularia and Sarcophyton, but less for Lobophytum. So, so this is just the slides that I want to share, and hopefully in future we can come up with a collaborative work to pin down what really what's the reason for coral bleaching, not just for marine heat waves, but maybe we can also identify some anthropogenic factors that exacerbates the impact of increased sea surface temperature, maybe some sedimentation, and among others. So that would be all. Thank you.
Yeah, thank you very much, Maria. I think Weidong is already in the come back, right? Weidong, I give the floor back to you, Weidong.
Yes, thank you, Samkia. It's very sorry for my broken connection. So it's my understanding here. So we already invite Augie and Ben share the knowledge there. So it's we are already 2 minutes left of schedule. We will move to the group discussion. So we after the presentation from the invited speakers and panelists, now we can have about I think it's 20 minutes of a group discussion to reflect what we have learned from the speakers and share the common interest into the future. So I think now the floor is open for group discussion. So anyone who would like to say something, recommendations, please. I think you just say open your floor and you can speak. So anyone would like to say, to give some comments or suggestions?
I would like to comment on Maria's wonderful presentation. Thank you so much for sharing your work with us. It's very, very impressive. You asked the question, how can we understand why some corals are bleaching, why other corals are not bleaching? I want to suggest that the satellite data are not sufficient for us to understand the heterogeneity of conditions on the reef. What we are finding, and I'm sure you know this, is that the satellite data can only capture the very skin surface, whereas many of the corals are living, most of the corals are living at 3 meters depth and below. Those conditions are different from the satellite. Also, the satellite cannot resolve the fine scale variability on the reef. So when we get the satellite information, the reef just looks like one blob. Whereas actually what's going on is there's a lot of heterogeneity. In reefs, there are temperature ranges of 5 degrees, 6 degrees Celsius, with some areas are very hot, some areas are very cold. This is the same in the bleaching event, right? So in a bleaching event, some corals are not seeing the same level of heat as other corals. So you might say, wow, That's because they are not bleaching because they're tolerant. But in fact, they are not bleaching because they are not hot, or they're not as hot. So the first thing we need to do is to be able to understand and know and quantify the fine scale variability in the reef at all depths. We cannot do that with instruments because we cannot instrument the reef at the density of instruments that we need and for the time period that we need that information. That's why we have turned to the models, the hydrodynamic models. These hydrodynamic models are so powerful. I do not generate those models. I team with a physical oceanographer to do that. I think that us in the coral reef community, we need to team up with the physical oceanographers to really know the reef and to know the conditions on the spatial and temporal scales of these ecological processes that are happening. I think we're in a new era now where we can do this. So I just want to put that out there because we are a mixed group here in this audience of biologists, oceanographers, maybe engineers, and I really think it's going to take all of us to resolve this problem, to resolve this issue.
Yes, and I fully agree with you. I think this marine heatwave is a very multidisciplinary topic. We need to work together from different aspects. I'm also very glad to say Gordon is producing excellent simulations there. So Gordon is always very passionate for such kind of high resolution modeling. So that is a good example. Yeah, maybe I have a question for you. It's the super reef is an excellent idea. So if we super reef has some kind of a thermal tolerance. But my concern is, does it mean that we will lose some biodiversity if we are focused on the super reef and the other species will be replaced by some specific species is more tolerant to the thermal pressure?
That's a really good question, and actually that's a question that we get a lot about super reefs. But in fact, within each species of coral, each species of coral, there's a range of thermal tolerance. So we are not talking about tolerant species. We are talking about the thermally tolerant end of each species. So our super reefs in Palau, for example, have the highest species diversity of all of the areas of Palau. So we are talking about super reefs are not just one species. They are mixes of species, mixes of taxa.
Okay.
And they are all driven to be thermally tolerant by the conditions to which they're exposed.
Mm-hmm.
So it's not just one species. It's really important to understand that we're seeing thermal tolerant across all coral species. Okay,
understand. So my information to share with all of us participants here is South China Sea and nearby region is a monsoon region. So it's we have several critical time for the coral reef bleaching. So as Somka mentioned, that is a pre-monsoon season. So pre-monsoon season is normally is May. So May is the most risky time. So I say from Maria's PPT that west of Philippine, in May is a lot high coral bleaching rate. So for South China Sea, so we have a South China Sea mini warm pool just western of Philippines. So for that area, before the South China Sea monsoon onset, the temperature is reaches a peak. So I also draw your attention to such kind of seasonality. So it's coral bleaching in this monsoon region. It's not throughout the year, but very much phase locked to the pre-monsoon season. But during monsoon time, we also have a extreme marine heatwave that is mostly associated with the monsoonal intraseasonal oscillation. So from my understanding, this marine heatwave it's a very broad temperature scale, from a synoptical scale like a weather to the interannual like El Nino, and even to climate change. So in that sense, we have to combine the physical study together with the biological study together to understand the drivers and the response, and to finally go to the solution. So it's, I think this is a very complex system to explore. I
Question
hope
for me, the most important question for where I see it from the physics is how to predict
yes.
marine heat waves in the future. But while we're talking about coral reefs, we want to predict the marine heat waves in the future at the reef scale, at the ecological scale. It's not useful necessarily to us to predict the marine heat waves on the ocean scale, on the ocean basin scale. We want to understand the effect on the reef system. But I think it's really hard to predict the marine heat waves in the future.
From my point of view, is a physical oceanographer will try to find out such kind of a predictability. So as I mentioned, it's a pre-monsoon is a time window for high prediction scale, and during monsoon associated interseasonal oscillation, we have some kind of not so satisfactory, but some kind of predictability. So I think all this knowledge from climate science, physical aspects can apply to the marine heat wave prediction.
For example, we want to know in Vietnam, right? We saw some sites in Vietnam that are affected by marine heat waves. Some of them are surviving marine heat waves. What is going to happen to those sites in the future? In the next 10 years, 30 years, how will those areas be affected by marine heat waves? How can we predict that? Because what we can do right now is we can test we can quantify the thermal tolerances of the corals at those sites in Vietnam. So we know they can survive 34 degrees Celsius, right? But how can we predict when that 34 degrees Celsius threshold is going to hit? If it's going to hit, when it's going to hit, that's what we need to know.
Okay, so let's hear Duan. So Duan would like to say something from the Vietnam point of view. So Vietnam is the upwelling there, and it's a critical point, critical important for the heat wave.
Yeah, actually as we don't understand very well about the study of upwelling in Vietnam, starting in 62. And we have many studies with involvement of not only Vietnam scientists, but also many countries from US, from Russia, from Germany. And actually, we understand the how to say the pattern of the upwelling. We found the variation of upwelling with high range, but actually as we don't aware, I have a project on the national project on the environment variation in South China Sea, and we have on content on the forecasting the upwelling. But up to present, actually, it is very, very difficult, not easy. So as mentioned by, I forget the name to our college, Chinese colleagues, about the
Chunzai.
Yeah, one factor to drive the heat wave is the upwelling.
Yes.
But we forecast upwelling. That is the thing.
That's the first speaker. Yeah.
We have done recently. Really, we have no final answers. That is the one thing is very important. So I think for the UN decade, today we have an incubator in the beginning. So I think we need to work closer together to do that. And as I mentioned in my presentation, the degree heating, okay, we understand. It is a hint case, not forecast. Happened already, yeah. But how to see? For example, we have we know in the 2010, 2016, we can see okay, when we have the level of degree heating week and then that Coral area bleaching, but not the same level and change a lot. It depends on other factors. So we should work together to answer the question, because we understand prediction as my presentation is the need, talking about the need on prediction, but prediction is a long way we have to work together. Not easy, especially at the 5 scale. Global scale is okay, but 5 scale is, yeah. So one gap I found for discussion today, we have a weak link between oceanographer and biologists. Okay, oceanographer work their work, and study coral bleaching work by biologists, but we have no tight link between two communities. Oceanographic, physical oceanography and biological oceanography have to work together. And for example, our Chinese colleagues have the new publication on variation of temperature in the South China Sea, but first time I heard. So after this meeting, may I receive the copy of the paper published by Zhang Wang from China, from Oceanographic?
Yeah, I will send you a copy.
Yeah. So yeah, not only for this case, but we need to work together to have the network.
Yes.
For long term. Yeah. Okay. Yeah, that is my. Thank you.
Yeah, fully agree with you. I think your point is very important. It's the linkage, the gap now is an interaction between the physical oceanography community and the biological study community. So we are in some time, and most time we are speaking the different language. We need to work together to increase our mutual understanding. So this is a critical point. Take notes. Anyone would like to say? We still have 5 more minutes before we conclude. So Augie is sorry I missed your talk. It's but I would like to ask for Indonesia. So you are in mostly in a southern hemisphere, and your marine heatwave is somewhat different with what we have. In your summertime, you have the marine heatwave is in Indonesia. Is any activity or initiatives to look at this marine heatwave, or what is the future potential for this work to be done from your national scope?
Well, thanks again, Wei Dong, for asking me. And I think our focus is mostly for marine life. I think it's quite similar to Thai and Vietnam, but we also pay attention a lot on the study of oceanography. It's like ENSO, El Nino, and Indian Ocean multi-dipole. So I think, well, as long as we work on the marine life, we still pay attention a lot on the physical oceanography or whatever oceanography in terms of the physics and chemists and biology as well. So that's all from me, I think. So I think marine life is very important for Indonesia, especially for biodiversity. But we pay a lot of attention also on oceanography, physics, chemist and biology. Thanks.
Yes, thank you, Ogi. I understand that LIPI is reorganizing now. It's hopefully you are in a good shape to move forward in a more efficient way. I also looking forward to working more effectively with the Indonesia community. So let's see. So I think Indonesia, Malaysia, Vietnam, Thailand, Philippines are all is a core reef triangle region. For this region, triangle region, the marine heat wave will be a very important process. We can work together. And yeah, let's have 2 more minutes for someone. So Maria,
yes, we don't. Yes, we don't. I
Yes.
think we will make a very strong oceanographers in Indonesia because you know that's LIPI Research Center for Oceanography. Now we split it into several research centers. So we want to make the strong research center for oceanography. So all the oceanographers from KKP, that's you know, BPPT maybe, will join RCO, and some the scientists who works a lot on the coastal, probably they would like to develop the other research center for them. So that's the news. That we work now for that. Thank you.
Okay, thank you, thank you. It's Maria. When I think it's the mini South China Sea Wampu. It's very close to Philippines, so for that reason, I think it will be a very much interested region to explore. So, Maria, do you have some experience to explore in that mini Wampu area?
Well, not at the moment, although we have long-term monitoring data in the South China Sea, but we did not really monitor coral bleaching because most of the reefs are offshore, but we have an information on that. So I just would like to add on what Anne Cohen suggested earlier to work with oceanographers. Actually, I'm currently working with some of our oceanographers at the Marine Science Institute who are focused on marine heat waves, and hopefully we actually submitted a proposal and hopefully it gets funded. Thank you.
Okay, thank you. So it's definitely we need some chemical interaction between our two communities. Yeah.
Yeah, why don't before
Yes,
you said we have 2 minutes before the end of this session.
Yeah.
I would like to say something, you know, because
Yes,
now I think that from our discussion we are in the same page now. We know that multidisciplinary science for this kind of marine heat wave and biology is very important. I think we can better understand and then useful for those kind of people to in the country, you know, even the government, even the public, or even the local fishermen can be benefit from that. We know that, you know, that today we are talking a lot about the coral. We know that coral is one of the main impact from the heat waves, but we still lack of knowledge about the other, you know, for example, about the fisheries and other. I think if we are going to move together in a multidisciplinary side, and we agree on that one, you know, already after our discussion. And then you say that incubator, the main target, we would like to do something in the next 10 years to along the line with the UN decade. You know, UN decade is also multidisciplinary side. They are very emphasized, you know, and then I think it's very, very good. I think under the leadership of Vaidong, maybe if you can, you know, in the future, today we know how many people participate in this forum, and then you interest. I think I believe that most of you interest on this topic. And then if we can come up with a group of the scientists from many fields, you know, and then working together in the near future will be very, very good. Today, this all from today, we come up with that kind, you know, the conclusion we are going to move together, and we have the lead of the people to work together in the future. I think is we can work even not only from the scientists from the region, even our partner also can be joined up, you know, particular and Cohen from US. US is very strong partner, you know, working with the WESTPAC, also is a member of the WESTPAC as well. Thank you very much.
Yes, thank you, Samkia. So I totally agree. So we will not focus on a coral reef, but also look to other systems like a fishery. So it's a marine heat wave is influence everything living in the ocean. So we have a very broad interest to host many more people to join us. So thank you. I think it's we can close our group discussion part and have less minutes to conclude to reflection. I will share my main impressions, and you can add more. So firstly, I think we have a very strong interest from all the participants on the marine heat wave process in South China Sea, and beyond that, in a more broader sense, we are interested in the monsoon ocean, heat wave over the monsoon ocean. So this heat wave over monsoon ocean is different from other regions in a trade wind region. So this is very unique. And this is one of the scientific drivers for our study here. The second point is we have a strong interest from South China Sea region countries, including Vietnam, Philippines, Malaysia, Thailand, Indonesia, and other countries, China, and also US. So it's we have a gathering a lot of common interest. We want to work together under the framework of UN decade. That is excellent and give us a good starting point. We will keep this discussion in a follow-up time and through the coordination under the RC WESTPAC. The third point is my impression here is we highly appreciate the multidisciplinary approach for this topic. So it's a physical community and biological community, it's ecosystem and the fishery. We need to work together. So as we already heard, there is a satellite data, there is an in situ observation, there is a very high resolution modeling, there is a lab experiment. Oh, that is a different aspect. So we should cook everything together and make them have a chemical interaction to come up with an excellent understanding. So I think this common understanding is very important. And finally, I think we already have a sound basis to move forward. Today we have a small group. I checked the number is more than 60 participants. So this 60 number is a good number. We can keep, yeah, I think WESTPAC will have a follow-up actions to trace or to promote all the energies coming up from this incubator. So we will follow up, we will keep going, and we will have a more specific discussion. I think that is all my expression or reflection from our incubator discussion today. So I invite you to add more points maybe I missed. So some of you would like to add more points. We will put into the input into a summary report, feedback to the plenary.
Yeah, why don't I have some suggestion, you know, from your conclusion, it already cover all, but I would like to propose, you know, is maybe if we can have the small group of those the people from different fields, you know, and you mentioned that to develop some kind of framework for this, you know, this kind of project or activity in the future. And then later on, if we have a chance to have face-to-face workshop or those kind of things, we can bring this a framework to discuss together with the wider group, you know, and then to take the action in the near future. I don't know that this kind of pandemic, how long it will take. It will take longer time. Maybe we can organize, you know, even a small group, come up with the framework, and then we have the big group and then share the framework for the discussion, you know, to move forward, right? Yeah, that is from my side. I would like to propose.
Yes, I look forward to the face-to-face meetings. So we have an online meeting for too long. It's getting somewhat tired. It's not so efficient. Okay, so anyone would like to add? There, Anne.
I would like to
what
just say thank you so much for inviting me to this meeting. You know, here in the US, we are often speaking with ourselves. And so it's so critical to get to be interacting with non-US, with different countries, to get to see what you're all doing, this fantastic science that's being done in other countries, and just so thank you for inviting me to participate. It's been really exciting, and I love meeting everybody. Thank you.
Okay, thank you, Anne. Thank you for joining us. I know it's it's very late night, right?
It is, and I've had a glass of wine, so it's
Okay.
Thanksgiving.
Okay, enjoy that holiday.
Thank you.
I think, yeah, so I think it's you have an excellent program. It's later on. I would like to give you more time. I know 15 minutes for you is too short. It's give you more time.
I didn't mean to complain. I didn't mean to complain. I'm sorry.
Okay. So I would like to hear you more later.
But thank you.
Okay, thank you.
Okay, thank you, Duan. So I think we have a lot of common understanding today. So we can, yeah. So I think later on we'll come up with a short summary report circulate to all the speakers. And I do not know that do we have all the participants, the list of all the participants, but technical support maybe have the record we can circulate to all the participants.
Okay, I am leaving for the next room.
Okay.
Nice to meet you. Thanks so much for sharing with us your research.
Bye-bye.
Yeah,
Great.
thank you very much, Anne, and nice to meet you, and hope to see you in the near future.
I hope to see you, Samket, and Lalita too. That was so much fun we had in Thailand.
Thank you all.
Bye.
For
Bye, Anne.
yeah,
Looking forward to see you in Thailand too.
Thank you
Thank
very
you.
much,
Thank
everyone.
you.
Bye.
Bye. Thank you.
Hello, Nan. So how are you now?
Good. I'm good.
Okay, it's a long time no see. So
Yes. And also looking forward to back to Phuket.
sure.
For me.
It's yeah. Where are you now?
In the Gulf of Thailand.
Okay, it's not in Phuket.
Not in Phuket anymore.
Oh, really?
Yes.
You moved to other institute.
It's belong to the MCR, but just different one. This is
in upper Gulf Thailand.
Yes, upper Gulf of Thailand.
What's the name? I visited that before. Yeah, I think.
It's the new one. So you have it's the new one. Taking care in the eastern part.
Okay.
Yes.
So hopefully I can visit you soon.
Of course, or we can see at the Phuket.
Okay. Take care.
Take care. Thank you. Bye bye.
Yeah. Bye bye.